This is section 6.3, double angle, power reducing, and half angle formulas. We're going to begin with the double angle formulas. And what we mean by double angle is the sine of twice theta, the cosine of twice theta, or the tangent of twice theta. You could think of the sum and difference formulas that we had for each of these trig functions, where now u and v are the same angle. So you could think of it like that. So the sine of 2 theta is equal to 2 sine theta cosine theta. Now, the cosine of 2 theta is equal to the cosine squared minus the sine squared. And the tangent of 2 theta is equal to 2 tan theta divided by 1 minus the tan squared theta. Now we do have some double angle formulas in summary here. So our double angle formulas in summary are here, and they are squared above. Now the double angle formulas can also be used with angles other than twice an angle. For example, we could have the cosine of 4 theta, and that is actually equal to 1 minus 2 sine squared of 2 theta. And we also have that the sine of A equals 2 sine of half of A multiplied by the cosine of half of A. So we can use these double angle formulas with angles other than twice an angle, a double angle. So let's go ahead and take a look at number 1. Now each one of these questions are a little bit different. So we need to go ahead and take a look at this. Given the sine of theta equals 5 over 13, and the tangent of theta is negative. So first of all, let's figure out what quadrant we're in. The sine is positive, and the tangent is negative. So we must be in quadrant 2. Okay, so now let's go ahead and draw our triangle. And we have theta. And if the sine of theta is 5 over 13, we know that the opposite is 5 and the hypotenuse is 13. So we have x squared plus 5 squared equals 13 squared. And that gives us x squared equals 144. I better write those out. And x is equal to 12. Okay, so now we can write the sine of theta and that's equal to 5 over 13, and the cosine of theta is equal to negative 12 over 13 in quadrant 2. Okay, so now we can find the sine of 2 theta. Maybe I'll move this in quadrant 2. And so now we'll go ahead, and it asks us to find the sine of 2 theta. So we can have the sine of 2 theta, and that's equal to 2 times the sine of theta multiplied by the cosine of theta, and that's 2 times 5/13 times a negative 12/13. Again, our cosine is negative in quadrant 2. And so, to simplify this, we would come up with negative 120 over 169. Okay. Okay. Looking at number 2, given that the tangent of theta is negative 5/4 and theta in quadrant 4. So theta is in quadrant 4. So taking a look at this, if theta is in quadrant 4, and that will help us draw our triangle. And if we're given that the tangent of theta is negative 5/4, that would be opposite over adjacent. So we could call this z. Z squared is equal to 4 squared plus 5 squared. That's equal to 16 plus 25, and that's equal to 41. So z is equal to the square root of 41. So, since the tangent is negative and we're in quadrant 4, we know that the cosine is going to be positive. Okay, so now let's go ahead and find the cosine of theta. So the cosine of theta is adjacent over the hypotenuse, square root of 41. And that's positive. So now let's go ahead and use our formula. They asked us to find the cosine of 2 theta. So the cosine of 2 theta is 2 cosine squared theta minus 1. And that is our third formula for the cosine of 2 theta. There's actually 3 of them. This is the one we saw here. We have one with a sine squared in it, one with the cosine squared in it, and one with both. So since we've just found the cosine of theta, we can say that the cosine of 2 theta is 2 cosine squared theta minus 1. And that's equal to 2 multiplied by 4 over root 41 squared minus 1. And now we can simplify that and say that that's equal to 2 times 16 over 41 minus 1. And we can go ahead and break that down. 32 over 41 minus 1, which would be 41 over 41. And we'd come up with negative 9 over 41. Okay. In number 3, we're asked to verify the identity. So I think we'll start on the right-hand side this time. So our right-hand side, let's do that in red. And our right-hand side is equal to the cosine of x plus the sine of x divided by the cosine of x minus the sine of x. Okay, so what we would like is a difference of squares this time in the numerator. So we'll go ahead and multiply the numerator and the denominator by the cosine of x minus the sine of x, all divided by cosine of x minus the sine of x. And the reason for that is we will actually have the cosine of 2x complete in the numerator already, because the numerator would be cosine squared x minus sine squared x. And as you can see, that's equal to the cosine of 2x. That's going to be equal to that, okay? And then divided by, and now let's go ahead and multiply those two binomials together. We have the cosine squared of x minus 2 cosine x sine of x plus sine squared of x. Now that numerator, like we said, should look familiar. That is the cosine of 2x. There's that double angle formula. Now, look at this denominator. We have cosine squared plus sine squared. And the cosine squared plus the sine squared is equal to 1. So we have 1 minus 2 cosine x sine x. And 2 cosine x sine x is equal to the double angle formula for the sine of x. And that's exactly what we have. Okay, looking at number 4, this time we'll start on the left-hand side. So a lot of times we'll start with the more complicated part, or a part that we can start breaking apart, okay? So starting with this left-hand side, okay, we will have the sine of 3x. So we're going to use this as the sine of 2x plus x. We don't have a formula for a triple angle, divided by the sine of x. Now, let's go ahead and use our formula for the sine of a sum of angles. And that's equal to the sine of 2x multiplied by the cosine of x plus the cosine of 2x multiplied by the sine of x. And that's all divided by the sine of x. Okay, so now we're going to apply the double angle formula here, here and here. Okay, so I'll do those in a different color so that you can see that. Okay, and we're still going to have the sine of x in the denominator. And so now the double angle formula for the sine is 2 sine of x, cosine of x, and we still have the cosine of x. And now we'll do the double angle. We'll write the double angle for the cosine of 2x. And we will use 2 cosine squared x minus 1. And we'll multiply that by the sine of x. Okay, so now let's go ahead and combine a few things here. We have 2 sine of x cosine squared x. And now we have 2, and I can write them in that same order. And why don't I do this? Why don't I write the first ones in that order? That'll make it a little more evident. We have 2 cosine squared x multiplied by the sine of x. And now let's distribute that sine of x plus 2 cosine squared x sine of x minus the sine of x. And again, still all over the sine of x. So now, as you can see, we have like terms. And we have 4 cosine squared x sine of x minus sine of x, all divided by sine of x. Okay, so now we can factor the sine of x out of the numerator, and we're left with the cosine squared x minus 1. And I think I meant 4 cosine squared x minus 1. All divided by the sine of x. And that leaves us with 4 cosine squared x minus 1. Okay, now let's apply the power reducing formulas. So we have the double angle formulas for cosine can be used to express even powers of sine and cosine in terms of the first power of cosine only. So basically what we have here is we have a power reducing formula that takes the even power, so you can see that's an even power, and an even power of a cosine. And what that does is it brings us to the first power of cosine only. So this is cosine to the first power and cosine to the first power. Okay? We also have that for an even power of the tangent. Okay? When the tangent is squared. And again, you can see it's in terms of cosine to the first power. Now, all of these have a double angle in the cosines. But let's go ahead and write the sine of 2x raised to the 4th power. Okay? And we're going to write that in terms of first powers of cosine. So the first thing that we probably want to do is we probably want to make sure we understand that the sine of 2x raised to the 4th power is equal to the sine squared of 2x all squared. So that's actually going to lead us to this. Now we're going to have the sine squared of 2x. So we're right here. And here, theta is going to be equal to 2x. So using that formula, we can write 1 minus the cosine, and again, we're going to have 4x now, all over 2, and this is squared. And you know, I really think that the best way to do this is to write this right below and be able to follow along. I think that's the only way. Because maybe we wouldn't know where that was coming from, okay? So our theta from the formula is 2x in our problem, okay? We can even write that. Okay, let's keep going. So now we have, squaring this, we will take the 1/4 out, factor that out, and we will have 1 minus the cosine of 4x all squared. So when we square 1 minus the cosine of 4x, we will have 1 minus 2 cosine of 4x. And now we're going to have a cosine squared of 4x. Okay, so now that leads us to, we will use, for the cosine squared of 4x, we will now use, and let me do that in a different color. Okay, so now we have 1/4, and we have 1 minus 2 cosine of 4x, and now we're going to have 1 plus the cosine of 8x divided by 2. Okay? Okay. Okay, so now we'll go ahead and distribute that 1/4. So we will have 1/4 minus 1/2 cosine of 4x plus 1/8 plus 1/8 cosine of 8x. Okay, combining our like terms, there's a like term, there's a like term. Okay, so 1/4 plus 1/8, we have 3/8. And now we have 1/2 cosine of 4x. And then we have 1/8 cosine of 8x. Okay, and we have the cosine to the first power here. So we have first powers of cosine. Okay, let's take a look at the half angle formulas and apply them. Okay, so if you go to the power reducing formulas and you replace theta with half of alpha, you will come up with these half angle formulas. We have the sine of the half of an angle, the cosine, and the tangent of half of an angle. And the plus or minus sign is determined by the quadrant of alpha divided by 2. So let's go ahead and try this in number 6. Use the half angle formula to find the exact value of the sine of 5 pi over 12. So we have the sine of 5 pi over 12, and that's equal to the sine of 1/2 of 5 pi over 6. So if we are in quadrant 1, we have that. And as you can see, half of our angle is 5 pi over 6. So really we would be in quadrant 2. But we don't need that really, because now we can say that using the half angle formula, we can have that that's equal to the square root of 1 minus cosine of 5 pi over 6 divided by 2. And that's equal to the square root of 1 plus root 3 over 2, all divided by 2. Now we will want to take care of that complex fraction, and we come up with, and we'll be under the square root multiplying by 2 divided by 2, and we will have 2 plus root 3 all over 4, and that's equal to the square root of 2 plus root 3 all over 2. And that half angle, this positive or negative, is determined by the quadrant of alpha divided by 2. And so half of this angle, or 5 pi over 12, would place us in the first quadrant. Okay, since that's this is in quadrant 1, 5 pi over 12. Okay, so now let's look at number 7. And in number 7, if sine of alpha is equal to negative 7/25 and alpha is between 3 pi over 2 and 2 pi, find the exact value of the tangent of alpha divided by 2. Okay, so let's begin with the information we're given here. The sine of alpha is equal to negative 7/25, and we know that alpha is between 3 pi over 2 and 2 pi. So let's go ahead and just first get our triangle drawn. And that should be alpha, not theta. And we'll have 7 and a 25. And then we will have x. We have x squared plus 7 squared equals 25 squared. So x squared plus 49 equals 625. X squared is equal to 576, and x is equal to 24. Now, we are in quadrant 4. And the sign is negative in quadrant 4, but the cosine is positive. Okay, so now let's go ahead and find the cosine of alpha, and that is 24 over 25. And the sine of alpha is a negative 7 over 25. Okay, so now it's time to find the tangent of alpha divided by 2. And that's equal to the sine of alpha divided by 1 plus the cosine of alpha. Okay, and we have that equal to negative 7 over 25 divided by 1 plus 24 divided by 25. It makes it really nice if we can just go ahead and clear these complex fractions right away. And so we have a negative 7 divided by 25 plus 24. And that's equal to negative 7 divided by 49, and that's equal to negative 1/7. Okay. I think that's good about right there. Okay. Okay, next we're going to verify the identity, and actually this is the last problem. Verify that the cosine squared of alpha divided by 2 multiplied by the tangent of alpha divided by 2 is equal to 1/2 sine of alpha. So let's begin on the left-hand side, a little bit more complicated on the left-hand side. And we have the cosine squared of alpha over 2. So we're going to use this formula right here. So it will be plus or minus the square root of 1 plus cosine of alpha divided by 2. So we have that this is equal to, this left-hand side is the cosine of alpha over 2 all squared multiplied by the tangent of alpha over 2. So we have plus or minus the square root of 1 plus the cosine of alpha divided by 2 all squared. And then for the tangent of alpha over 2, we have the sine of alpha divided by 1 plus the cosine of alpha. Now, squaring a plus or minus doesn't matter. So the plus or minus does not matter when being squared. Okay? So now we can just remove that root, and we have 1 plus the cosine of alpha divided by 2 times the sine of alpha divided by 1 plus the cosine of alpha. So these cancel. We end up with the sine of alpha divided by 2. And of course, that's equal to 1/2 sine of alpha. And that concludes this video.